Hello everyone, Mr. Terminal here. We are starting with ELK Stack. I found this on Google, the image. So what is ELK Stack? Let me just do a little bit of setup so I can explain. Become root. All right, let's go to text.txt. What is ELK Stack? We are beginning with from very zero. If you don't know anything, it's fine. If you know something, well, you will learn a lot along the way. ELK is a combination of Elasticsearch, Logstash, and Kibana. What this individually does is they are individual tools as well, but they are stacked to make something more useful. They're all by Elastic, and use cases are different, but together, if you're using them, it's for log analysis and storage and to understand what your logs are doing. If your company's infrastructure or whatever client's infrastructure is that complicated, or so we need to know what's happening and what kind of trends we are getting in that log. So it's also used in machine learning, not ELK Stack, but Elasticsearch. So in ELK Stack, the use case is something like this. You can be getting logs from anywhere, whatever, Google Cloud, AWS, your own hosted file system, and these logs are then processed by Logstash. And what's processed here means it looks for, well, patterns in this log. It's this log you're getting is completely random, and when it is processed, it is more sensible to who, not to us, to Elasticsearch, and that's what it does. It takes a more sensible data from Logstash. You cannot directly give to Elasticsearch unless, of course, it's already processed in that way. And Elasticsearch is an analytical tool. It's based on Apache Lucene engine, search engine. So it has its own way of storing and processing data. It is not a database, however. That is something to be noted. But if you know other databases, then this is going to help you understand Elasticsearch more easily, because it does work fundamentally in that way. And once it gets this data, you can analyze it, and it's very, very fast, extremely fast. We'll get into that soon. And Kibana uses this data processed by Elasticsearch and helps you visualize the data. Not only that, Kibana helps you interact with Elasticsearch in more, well, understandable way. You can interact with Elasticsearch with shell, of course, but it's more, technical. So if you want to do, it's same thing. It's GUI versus CLI. CLI takes a lot of knowledge and study to interact with. So you can Elasticsearch individually is a perfect working tool, but to interact with it, to visualize the data, Kibana is used and helps the stack, all the use case. So for the stack, that's the only brief about it. We are going to start with what Elasticsearch is. And what you need to know is stores data in JSON files. And let's go from bottom to top, right? So the most fundamental, let's say create a JSON file. And the most fundamental would be a key value pair. Name, let's say Mr. Terminal. This key value pair is the simplest deep down inside Elasticsearch. This is the most atomic part of it. Let's say this is another field. The key value pair, this is another field. So you have two fields here. A key value pair is a field. And what Elasticsearch is, it is aware of each and every field that you have entered, that the data you have, all of the data is in key value pair, and it is aware of all of it. And what I mean by aware is, I mean, if you go for SQL, you have tables, right? You have row into column structure. And if you search for something, query for something, Elasticsearch does have its own query. We will get into that later. If you query something in SQL, it will look through all of the table. And that's why it's so slow. But in this case, it is directly aware of where the field is and what you're searching for. And that comes by the power of indexing. So what is stored inside is documents. So in Elasticsearch, these are called documents. What are documents? These are a group of fields. But you just can't say this whole thing is a document. It might be a document, it may not be a document. You don't know that. It's field aware, it's not file aware. That's what you have to understand. So what I mean by that is document is logical fields, logically related fields. Okay. They are not randomly given into one document. So a document knows what it consists of. So, and these documents are further pointed towards using an index. So you cannot say it's a group of documents. More likely it's indexing is pointing towards those documents logically. Okay, I know that's not clear. Let me understand that. So if a document is talking about consists of fields like health is fine, and B document is talking about health is well, unwell, and C document has a field among many fields. It's not a single field. Among many fields consist of well, Toyota. So what indexing does, it will separate these documents. So index 1 will have A and B, and index 2 will have C. So they are logically separated. So when you query something, or you can think about it like a search engine. When you search health, it won't look into index 2 at all. It will directly go to index 1, and hence the faster speed, right? That's the working of index. It's a logical separation of these documents. Index itself does not store data. That's something you have to understand. It's only pointing towards the data. It consists of what is where, not the what. Got it? And index, when you move on top of index, what do you have is shards. Now what is shard? This is where the data is actually stored. Okay. It's not stored in index, it's not stored in documents or in field. This is actual storage of data. But it is not completely random, it is also intelligent. In what way? For now, you need to know it's all documents come under shards. Or shard, whatever the case be. Let's start with next step so you can understand how shards really work. Shards are loaded on or work on or come under node. A single node can consist of many shards. So if you have, let's say, one node, it's a group of shards. And what is a node? Node, you can imagine as a virtual machine. It has its own RAM, CPU, etc., etc. You know what a virtual machine is. So it's a separate computer, if you want to say that. And it's keeping these shards in it. Okay, so that's where the shards are located in a node. Now here is where it becomes interesting. So let's go back to this example. So when it is indexed like this, according to these fields. So if two documents are relatable, they are in a shard. And let's say one document is of different type, then it's in another shard. Let me explain it to you in a better way. So you have one node, you have all the shards. Shards are again logically distributed. So one shard could be, for example, about hospital data, one could be about car, one could be about etc. etc. You have, let's say, like 5 shards. One is about insurance companies. It consists of data in a logically distributed way. But when you have one node, and if you search, it will look through all of the shards. Is the sense right? So the utility of shard is not utilized. I mean, what is the point left of it being in a hospital, car, etc.? Sure, of course, it will go to the hospital once and then into the data, but it had to check if it's not these, right? If the data you were searching for is in hospital, it had to be sure it is not in other things, because all of your shards are in one node. But here's what is interesting. When, let's say, you increase 5 nodes, and each node will have one shard. Now, when you search something related to car, it will directly go to the car node, and hence the car documents. Before that, of course, it will go to shards, and then it will go to the proper field and will give you the result. Understood? So, and how are nodes controlled? There's one node top on something top of nodes, that is a cluster, which is directly a group of nodes. That's all. So all your interaction is with the cluster. Everything you do is with the cluster. Cluster manages everything. You can tell I need more nodes. Of course, more nodes means you need to have that much RAM, CPU power, or that much machine power inside your host. If you're doing it on a cloud, you can of course extend it as much as you want with the cost of price. But if you're doing on your local machine, you have to keep in check what your node consists of, how much you're allocating to that. And of course, from this, you can directly drive more the nodes are, the faster it is. Because you are chopping down data logically, so you're not searching in places where it is not required to search, unlike other databases. That's why Elasticsearch is so fast. For example, it is also used in auto-completion. Auto-completion is when you type in what is in Google, you get a bit of results, right? So you get those results so fast. Basically, you are looking through all of the data with these words, what is. How is it giving you results so fast? Because it is not looking through all of the data. It is only looking at the data which said what is, which had these keywords, key value pair in case of Elasticsearch. That's why Elasticsearch is so fast. I think that covers it for this video. Let me just brief it. So we interact with a cluster. Cluster is a group of nodes. Nodes consist of shards. And shards are a group of documents. Documents are a group of fields. Field is a key value pair. That's how you break it down. Oh, I missed one thing in the architecture. Each shard has replicas, so it's at the same level. You don't do anything with replicas. It is the way the architecture is. So if your of course important data is in one shard, if you distribute it that way, all of your data can be in that shard in some cases. Not advised, but it can be. So if it's destroyed, then what? You cannot risk losing it. That's why there are replicas. There are more than one replicas for one shard. But so if you lose the shard, replicas replace it and replicas are created again. So you don't really lose data. That's the part of it. So it's at the same level. It's and the side is not really interacting with anything. So nodes don't go to replicas, obviously. Loads go to shards, but they do have replicas as a backup. Okay, and in next video, we are going to interact with Elasticsearch and see how things work. See ya.